Good morning. Okay, so today what we're working on is section 5.5. Hope everybody's doing well this morning. Evaluating quadratic functions. Okay, so this is, if you're following along in your packet, this is pages 106 and 107. Okay, so this starts off, some of these are fairly basic, but then we're going to kind of connect it to the actual graph, and we're going to look at some things on the calculator. Okay, suppose f of x equals 2x squared minus 6x plus 3. So far, you know this is a parabola. If you were to graph this, a parabola opening up. Find f of negative 2. Okay, there's a couple ways we could do this. We're simply going to find f negative 2 first by plugging it into the equation. So f of negative 2 is going to equal 2 times negative 2 squared minus 6 times negative 2 plus 3. Simplifying, 2 times 4, negative 6 times negative 2 plus 12 plus 3. So we get 8 plus 12, which is 20 plus 3, 23. Okay, find f of 5. F of 5 equals 2 times 5 squared minus 6 times 5 plus 3. So that's 5 squared is 25, so 2 times 25 minus 30 plus 3. 2 times 5, 50 minus 30 plus 3. 50 minus 30 is 20 plus 3, 23. What do you know? We get the same thing. Okay, now let's look at this on the calculator. So our graph is going to be y equals, or f of x equals 2x squared minus 6x plus 3. Let's go to your TI Inspire. Okay, so you can open a new document, add a graph. Let's add this. This is going to be 2x squared minus 6x plus 3. Enter. Okay, now remember how we plug in values. You're going to go menu. If we want to just find values, plug in an x and find the y. Go menu. 5. So graph trace. All right, menu, trace, graph trace. And now at this point, you can plug in any x value you want. I'm going to move my face out of the way. We wanted f of negative 2, so type in a negative 2, hit enter. Let's try this. Negative 2, hit enter, and it gives you your y value. So it actually changed our window for us. We didn't have to modify the window manually. Okay. So when x is negative 2, our y value is 23, which is exactly what we found. Okay, I want to, okay, and I'm going to flash my computer. Okay, better. Okay, now let's plug in the other one. We wanted f of 5, so let's plug in value of 5. So you're just going to type in 5, hit enter, and you can see our y value is there, 5 comma 23. So you can see that down here at the bottom of the screen. So that's the easiest way to quickly plug these in if you wanted to do these with your calculator and see what this actually means. Okay, let's just for fun change the window zoom. Let's just do our window settings manually. We know that those y values were 23, so we can go from negative 10 to positive 10. That's fine. Our y min, let's go from negative 10, and our y max, let's make that, I don't know, 30, so we can just see a little better what our parabola looks like. And if we were to type in the line y equals 23, okay, so let's go to tab. Tab is going to let you write in another function, 23. And we can see when y is 23, these are the two values. This is the y value for our two x values. Okay, so again, if we did a menu trace, so menu 5 for trace and graph trace. So the first one we did, we plugged in a negative 2. So negative 2, hit enter. And we can see we're right there. Now notice this is blue. If we do arrow up, it'll jump to the other function. Now notice this is a point on both functions. So right now we're on the red function. If we go up or down, it just toggles between the two functions. Okay. Now if we wanted to type in the value of, what was this value? Positive 5. Hit enter, and we can see our y value is 23, 523. Okay. And you can arrow up and down to toggle between your two functions. Okay. And let's just type in 0 for fun. This will find our y-intercept, and we can see our y-intercept there is 3. If we arrow up or down, it'll jump to the other function. And obviously this y-intercept is 23 because it crosses, it's on the line, y equals 23. Okay, so let's go back and continue. Find x algebraically and graphically on your TI calculator if f of x equals 4. So when the y value equals 4, so we're going to plug in a 4 for the f of x and set that equal to 2x squared minus 6x plus 3. Okay. Now we're just going to solve this quadratic equation the way we would always solve a quadratic equation. You're going to subtract 4 from both sides to get all the terms of the quadratic expression by themselves. Subtract 4 from both sides, we get minus 1. And now we have to solve this. So we can either solve this by factoring if it factors, or we can solve this using the quadratic formula. Okay, let's solve using the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared, so 2 squared minus 4 times 2 times negative 1 over 2 times a, so over 4. Okay, so we get 6 plus or minus, that's going to be 4. 2 negatives makes a positive, so 4 plus 8, so rad 12 over 4 equals, and that's 6 plus or minus, that breaks down into rad 4 times rad 3, so the 2 rad 3 over 4. Okay, we can, each of these we can reduce with the 4, and we'll get 3 plus rad 3 over 2. Okay. So the x values are going to equal, x will either equal 3 plus rad 3 over 2 or 3 minus rad 3 over 2. All over 2. Okay. Just for fun, let's look at what this equals on our calculator. If we just give it a, just plug in, just find a decimal value. So control divide 3 plus square root of 3 divided by 2. Do control divide. So that's going to be about 2.366. And then we can arrow up, highlight it, hit enter. And now I can just change that to a 3 minus rad 3 over 2. Oops, I forgot to do control divide to get a decimal. 0.634. Okay. Now let's look at this on the calculator. I'm going to go to my screen so we can see this a little better. I'm going to hit tab, and I'm actually going to arrow up. We don't need y equals 23 anymore. We want to graph y equals 4. Okay, and find our points of intersection. Let's see, it looks like we may have done something wrong. But let's see. Let's do menu. We can do analyze graph, or we could do geometry. Let's do geometry to find our points and lines. Then we can find intersection points. Now it's asking us, oh, I did not mean to do that. How do we get out of that? Okay, I just messed up that. So if that ever happens, this is not a bad thing to do. Let's do tab. Let's go back up and let's fix that equation. Sometimes you accidentally touch the graph. It can be touchy. And it changes your graph. It actually moves it and changes the equation. So let's change this back to what we wanted the graph to be. 2x squared minus 6x plus 3. And sometimes that's frustrating. Okay, so let's do menu, geometry, points and lines, the first one, then intersection points. Okay, now you can hover over this and it's asking you, it tells you what to do to find your intersection point. Click on the first graph, then click on the second graph. Click on the first graph, click on the second graph, and it's going to find your points of intersection. Let's move this over. That one's 3.15. Okay, so we did something wrong. Let's figure out what we did wrong. Okay, these should be our values, 3.158 and negative 0.15. We graphed y equals 4, and we graphed y equals 2x squared. Actually, you can move these out of the way. You just kind of grab it and you can move it to where you can see it. 2x squared minus 6x plus 3. Okay, let's go back to our work and find our mistake. This can happen. You can make a mistake, and that's what I love about the calculator. You can check your work. Okay, so 4 equals 2x squared minus 6x plus 3. Subtracted that. Okay, x equals opposite of b, plus or minus. B squared. I did a squared. This should be b squared. Sorry about that. Negative 6 squared, which gives you 36 minus 4ac. So that's going to give you 36 plus 8. Okay. Oh, wow, this eraser. You were probably screaming at the screen knowing that I made that mistake. So we got square root of 36, and that's plus 8, so 44, which reduces to square root of 4 times square root of 11. So we've got 6 plus or minus 2, we're at 11 over 2. Simplifies into 3 plus, we're at plus or minus, we're at 11 over 2. So let's plug that in and we can check our answers. Okay. Actually, I'm just going to arrow up to this. The only thing that's different is that we're at 11. And another way, instead of doing Control Enter, if you enter a decimal anywhere in your expression, it's going to, that's your cue to them to give you a decimal answer. Okay. So I put in 11 point, like 11.0, that's the same as 11. Okay, but since I put a decimal in there, it gives me a decimal answer. So negative 0.158, let's just double check that with our graph. And that was this one over here. Okay, now if we go to the other one, we want 3 plus we're at 11. And we have the decimal in there. So 3.158. Okay, so 3.158. So those are our two solutions to this problem. Okay, so it was find x algebraically. So these were our two values of x. You could write x equals 3 plus red 11 over 2 and 3 minus red 11 over 2. Okay, next one. Find the x-intercepts algebraically and graphically on your calculator. So algebraically, we're just going to set 2x squared minus 6x plus 3 equal to 0. So x equals opposite of b, plus or minus, square root of b squared. So negative 6 quantity squared is positive 36 minus 4 times 2 times 3, all over 2 times a, 2 times 2. Okay, 6 plus or minus the square root of 36 minus 4 times 2 is 8. 8 times 3 is 24. So 36 minus 24 is 12 over 4. Okay, which is 6 plus or minus 2 red 3 over 4. Or we can factor out a 2 and then reduce it with the 4. So 3 plus or minus rad 3 over 4. Okay. So if we want decimal answers there, 3 plus red 3 over 4 is approximately, and 3 minus red 3 over 4. It's approximately, let's look at our calculator. The graph doesn't give you an exact answer. Okay, so 3 plus red 3 over, sorry, that should be over 2, right? Up here when we reduce that, that should be over 2. Divide by 2, divide by 2, divide by 2. Okay, and so we get, this one was 2.366, and this one, change that to a minus. .634. Okay, let's check that on the graph. Okay, we're finding the zeros. So there is under menu. Now here you probably want to do analyze graph. And then number 1, find the zeros. Okay. Now, which graph do we want to find the zeros of? Well, we're not finding the zeros of that horizontal line. We're finding the zeros of this graph. And now it's asking me, see, there's 2 of them. So we have to go to the left. It's asking for a lower bound. Somewhere, anywhere to the left of this, that's the 0 we want. Don't put it on the 0, go to the left because they want a lower bound for that. And click on that. And then right there, it's going to find your 0. And you can actually keep going and it's going to find, actually it only finds 1 at a time. So hit enter. There's our first 0. We can move that out of the way. 0.633 or 0.634. That's what we got. Let's find the other 0. Menu, analyze graph, 0. And now which graph? Again, we want this graph. We want the lower bound. So that's the 0 we want. Don't put it on the 0. Put it to the left of, or a lower bound. Hit click and then shade to the right. And now your upper bound is there. It's going to find your 0 between those two x values. So we get 2.366. So those are the 2 answers that we got. Okay. Now, given this, find x if y equals -2. So we're basically just finding, this is just another graph. Find your x values when y equals -2. We could do this algebraically or horizontally. If you understand this, feel free to fast forward through this, but I'll solve this one. Y is -2, so -2 equals -3x squared plus 2x plus 4. Add 2 to both sides, 0 equals -3x squared plus 2x plus 6. Okay, solving for x using the quadratic formula, opposite of b, plus or minus square root of b squared, 2 squared is 4, minus 4 times -3 times 6 over 2 times a. Okay. So -2 plus or minus square root, that's going to be 4 plus 4 times 3 is 12. 12 times 6 is 72. All over -6. Let's reduce. Let's double check that. Yep, that's right. So -2 plus or minus the square root of 76 over -6. Square root of 76 reduces. I know that we can take out a 4. Oh, you can't take out a 4. We could take out, yeah, we can take out a 4. Okay, so square root of 4 times the square root of, that would be 119. Okay, so 4 times 19, yep, that's right. So that breaks down into -2 plus or minus 2 rad 19 over -6, which we can reduce to -1 plus or minus rad 19. Notice I divided both those by 2 and divide this one by 2. So -3. So your x values will be those. Okay. All right, let's go to the next page, and we're gonna wrap this up. Use the discriminant. So now we're going to use the discriminant to determine if there are any real solutions. If the function has a real value for the given value of y. In simple terms, what are we being asked to do? We're using the discriminant to determine if the function has a real value for the given value of y. For instance, y equals this function. That's a parabola opening up. So does this parabola ever cross the line y equals -3? Okay, so basically what we're asking, does this line, this is a horizontal line, cross through our parabola? Okay, there's a couple pictures of this in the book. If you look at page 196. Okay, these two graphs right here. Okay, so if you were asked, if you were given this equation for this parabola and said, does this, the y value of this parabola, does it ever equal -5? Okay, so basically what you're being asked is, first of all, does this parabola open up or down? And is the vertex above or below this line? Okay, so if we look at this, the equation of this parabola, we'll know if it opens up or down based on your a value. If your a value is positive, so clearly the a value is positive because it opens up. So in that case, is the vertex, which is the minimum value, the smallest y value for this function, is it above or below this line? Okay. Another example, this one. If you were given this equation, clearly the a value is negative because this parabola opens down. Does the y value of this parabola or of this function ever equal 7? Okay. And you can use the discriminant to determine that. But this is what you're being asked to do. So does it ever equal 7? Well, you can tell from the equation that it opens down. So once you know it opens down, you're really asking, is the vertex of this parabola above or below a value of 7? Okay. So the answer, does the y ever equal 7, would be no. Does the y ever equal 3? Well, yes, it would. The y value would equal 3 because clearly the vertex to this graph, this parabola that opens down, is bigger than or above a value of 3. And then these two are the x values, so you'd find the x values where this function, the y value of this function would equal 3. Okay. Simple terms, what are you being asked to do? You're being asked to look at the discriminant, use the discriminant to determine, does the parabola intersect the horizontal line given by y equals whatever that value of y is. So let's just put y equals k, meaning some constant. Okay, so does this parabola ever intersect this line of y equals -3? You don't actually have to find the x values. You could. We just did a few problems on the previous page where you found the x values where the y value is equal to -3, but we're not being asked to do that. Does the y value? If we were to plug in -3 for y, so -3 equals 7x squared minus x plus 8. So let's add 3 to both sides. So 0 equals 7x squared minus x plus 11. All right, let's find the discriminant. The discriminant will tell us how many solutions there are to this equation. Okay, so b squared minus 4ac. Remember, just a quick recap, if b squared minus 4ac is greater than 0, there are two real solutions. If b squared minus 4ac equals 0, there is one real solution. If b squared minus 4ac is less than 0, there are 0 real solutions. But there are two imaginary or complex solutions. Okay, so that's a recap from the previous lesson. So b squared minus 4ac equals -1 squared minus 4 times 7 times 11. Okay, so that's going to be 1 minus 4 times 7 times 11. That's 28 times 11. 308. 1 minus 308, so negative 307. That's negative, okay? So you just, the discriminant, determinant of the function has a real value for the given value of y. It does not, because the discriminant's negative. So this parabola opens up, and clearly the vertex is going to be above the line y equals negative 3. So you would say no, okay? There are no real values of x for the value y equals negative 3 on this parabola. Okay, let's try this one. Let's find our discriminant. B squared minus 4ac is equal to, we didn't do the first step. First, we have to plug in 2 for y. So 2 equals 8x squared plus 2x minus 15. Subtract 2 from both sides. Let's find our discriminant, which is b squared, so 2 squared, minus 4 times 8 times negative 17. So we get 4 plus 32 times 17. Clearly going to be positive, so 544. So the discriminant is 548 positive, so yes. Okay, there are two values of x. Two real values of x on this parabola where y equals 2. All right.